Right, I'm going to do a couple of questions from a recent test I set. First of all, we're going to try and solve this equation cosec squared 2x minus cot 2x equals 1. And we're going to use the identity cosec squared x is equal to 1 plus cot squared x. So we're going to replace the cosec squared 2x with 1 plus cot squared 2x. So we get 1 plus cot squared 2x minus cot 2x equals 1. And let's just, now we can see we can cancel out the 1's, and that just leaves a 0 on this side. So now we're able to factorize. So we take out a factor of cot 2x, and that leaves us cot 2x still here, minus 1. So cot 2x times minus 1, that gives you cot 2x equals 0. So therefore, either cot 2x equals 0 or cot 2x equals 1. Take that from the brackets. Now, what most people do here is they realize that this is just going to be cot 2x is just 1 over tan 2x. Now, if you do 1 over 0, you get an undefined thing, and that causes a lot of problems here. Let's just leave that for one side at the moment, and let's just look at what happens when we do cot 2x and turn that into tan 2x, and we still get equals 1. You realize when tan 2x equals 1, you should know that 2x equals 45 degrees. We're working between 0 and 180. And if we put that into the unit circle, in your cast diagram, I teach my sets to remember as all stations to a city they know beginning with C. And we actually live in a town which actually it begins with C, so they remember it's all stations to that town. Now, we're at 45 degrees, and we're looking at where tan is also positive. Well, we draw a line straight across that quadrant, and you realize that this is 45 degrees by symmetry. So the next value, if that's at 180, round here you get 45 and that you get 225. So another value at 225. Now it's all important you do it at this stage when you do the inverse tan stage, because you know how often tan occurs, right? You know it reoccurs every 180 degrees. And you could just remember the formula to do it. Just add on 180 degrees to every value. And then you divide throughout by 2. So we get that x equals 22.5 and x equals 112.5 from this answer. Now let's go back to cot 2x equals 0. Common mistake on this one is to think, well, okay, I've got tan 2x equals undefined. Well, and then think, oh, it's undefined, I can't work it out. Let's look at where cot 2x does equal 0. Here's my graph of cot 2x. Remember, cot is just 1 over tan. So wherever tan is undefined, cot equals 0, which is here and here. So we've got these two points here and here where the cot 2x equals 0. And it happens at 90 and 270. So therefore, 2x will equal 90 or it will equal 270. So therefore, x equals 45 or 135 degrees. Now let's just go back to look at the range. We're asked to find between 0 and 180. The best way to work out the range is to think, well, I'm dealing with two x's. I know I'm going to look for 0. If I take x and scale up, 0 times by 2 is 0. 180 times by 2 is 360. And you look at this 2x stage for all the values between 0 and 360, and that's what I did. If you're unsure about this, you could just actually find loads more, and then when you divide by 2, just pick the ones that are in your range and get your final answers of 45 and 135, also 22.5 and 112.5. Now, the second question in this test, given that sine x equals 3/5, use the appropriate double angle formula to find the exact value of sec 2x. So let's start off writing out what sec 2x is. And sec 2x is equal to 1 over cos 2x. Now we have a double angle formula. We have several choices for cos 2x. You could have 2 cos squared x minus 1, or you could have cos squared x minus sine squared x, or you can have 1 minus 2 sine squared. Now given that we're given sine x and we don't know anything else about the value, we ought to use the one involving sine. So we get 1 minus 2 sine squared x. Substitute sine x as 3/5. So we get 1 over 1 minus 2 times 3/5 all squared. 3/5 all squared gives you 9/25. So that's 1 over 1 minus 2 times 9/25. Then let's just take this up here. And we get 1 over 1 minus, times that by 2, you get 18/25. And then take that away, and you get 1 divided by 7/25. 1 minus 18/25 is 7/25, and if we divide by that, we would just reciprocate the answer to get our final answer. Okay, in the last part of our test, we're going to prove that cot 2x plus cosec 2x equals cot x. Now when you're doing these proofs, it's always important that you just take one side, rearrange it until you get the other side. Now, a rule of thumb is always take what looks most complicated and then try and make it simpler. So in this case, we're going to take the cot 2x and the cosec 2x. So we're going to take the left-hand side, and we're going to turn this all into coses and sines. Normally I'd say avoid that, try and use a formula relating cots and cosecs, but actually they're all to do with squares, and we don't have any double angle formulas comparing cot and cosec, but we do have double angle formulae with cos and sine, so hence why I'm going to turn it all into coses and sines. So cot is 1 over tan, tan is sine over cos, so therefore cot is cos over sine, and cosec is just 1 over sine 2x. Now let's just use our double angle formulae. So we got cos 2x is equal to 2 cos squared x minus 1, and we know we've got this over the same thing, so we can add on that plus 1 here. So these are obviously going to cancel. We got sine 2x equal to 2 sine x cos x. And we can see that we're going to cancel out a cos here, and we're also going to cancel out the 2's, and that will just leave us cos x over sine x, which equals cot x, and that equals the right hand side. So we have proven our relationship.